Alright, so continuing on with the grade 12 general questions, I am going to work on 3.4, which is the equivalent resistances of mixed circuits. So I've made a few videos on mixed circuits before. I'll try to find the links and share them with you. I've done the basics of circuits and I've went through big mixed circuits. But I'm going to do the focused questions this time round. Let's see, what's the total resistance here? So now, because we have a series and parallel combo, I need to break it down one step at a time. This is in series with all of this. This whole junction together, as you can see, is parallel. This is in series with this. So to find the total resistance will be this plus this. So let's figure this out. This is going to be 1 over 6, I'll build a little bracket, plus 1 over 3 to the minus 1, and if my thinking is correct, is always smaller than the smallest resistor. You can check, I believe that should be 2 ohms. So that's my estimation. Then what I will do is I will see that this is 2 ohms, 2 plus, this is also 2, 2 plus 2 is 4. My answer is B, and that is actually correct. Very good. So this is 2 plus, why am I writing it again? This plus this. 2 plus 2 equals 4 ohms. Figure that out first, then you add this one. Let's see what else we have. We have another setup. It looks a bit like this. How do we do this one now? This is parallel. A lot of students just do 1 over this, 1 over this, 1 over this. No, that is not what you do. You're going to have to do 2 steps. I can now see that these two are together, and all of this is in parallel with this. So a little bit different from the previous question. I can simplify by bringing these two together, then I can do this one. So these two are in series with each other, 7 and this, so I can simply add these. If they're in the same line, I can simply add them. I will do this branch here first, so I will write it out over here. 7.6 plus 5.8. No more estimations. Let's use our calculator. 7.6 plus 5.8, and I will get 13.4. 13.4 ohms for branch 1. This whole thing is 13.4. I now need to find this total. So they're parallel, so I will do 1 over 13.4 in a bracket, plus 1 over 4.3, close the bracket, minus 1. Let's check. Let's open up the bracket, 1 over 13.4 plus 1 over 4.3, close that over, and I'm going to do it to the power of minus 1, and I will get 3.25. 3.25, and that closest answer is B, 3.3, rounded up. Okay, now we have this. I can now see that I have these two in parallel with this. I need to add these together. This is series with these two that are in parallel. This is in series with these two. These two are parallel. Hope that makes sense. It might be a bit confusing, but if I zoom in on this and focus just on this, I can clearly see this is parallel. I can find the parallel. Once I've done that, I will see this whole resistor and add it to this one, because this is in the same path as this one. I'm hoping it makes sense. Let's try. I will have to do the same thing again as I did above. I will do the same idea, but now it's going to be 1 over 10.9, because these are parallel, 1 over 6.7, and in a bracket, minus 1. Let's do it. Opening up the bracket, 1 over 10.9 plus, I will do 1 over 6.7, and I'm going to close the bracket to the power of minus 1, and I will get 4.14 ohms. And now this is 4.14 plus 2.4, so I'm going to plus 2.4. I will add these two because they're in series, 2.4. And if I do this, I should get 6.54. 6.54, I'll just do that. And clearly the answer is here, 6.5. Amazing. And this page is talking about this 3 different devices, and I will uncover the answers because there's going to be a lot of writing. This is, of course, a fuse. So does it not come up? Oh, no, it doesn't come up. I thought I covered up the answers. This is a fuse. This is a fuse, and it's designed to melt. It's designed to break if too much current flows. And if it breaks, it stops the current from flowing. So if this breaks, it will stop the current from flowing in the circuit, protecting the circuit. This is a ground fault interrupter. This is a ground fault interrupter. I'm not going to write the whole thing out. You have this document with the answers already there. But anyway, this checks the difference in current. You have the current coming in and the current coming out. And if there's a conflict, if there's a change, if there's a difference, it just turns off the circuit. Over here, we now have this circuit breaker. This is a circuit breaker. This is similar to a fuse, but you can reset it. What happens here is if too much current comes in, you have this bimetallic strip. This is like two metals stuck together, and if you're good at chemistry, when they get hot, they expand. Metals expand. One will expand more than the other, so then that will just bend it out the way. And if it starts to bend out the way, it stops touching the circuit. It opens the circuit in the sense that current no longer flows. So it switches. And then you can reset it by flicking it back. So that happens when it's like a stormy weather, when it's raining and flooding outside and all your lights turn off. You have to go find the box and you flip the switch. That's what you're doing. You're flipping the switch to turn the circuit breaker back on again. And that's the end of this. Thank you.